Today we're going to be talking about our fourth and final method for solving systems of equations. Up to now we've covered three. First we started with graphing, which works really well when both of our equations are in slope-intercept form. We talked about equal values method, which also works really well when both equations are in slope-intercept form. And then we talked about the substitution method, which works well when our equations are in two different forms. One is in standard and one is solved for one of the variables. Today we're talking about elimination. And elimination is a good method to choose when all of the equations in the linear system are in standard form. So remember, standard form is ax plus by equals c. It's when all the variables are on the same side together. So when we see all of the equations in our system in standard form, this is the method we want to choose. Let's spend just a couple of quick minutes going through the 5 steps we're going to use to solve by elimination. Our first step is to write the equations so that the x terms line up and the y terms line up. We want to stack our equations so that like terms are right above each other. For example, here we have a system of two equations. I can see they're both in standard form. X and y are on the same side together. We have 2x plus 3y equals 6, negative 2x plus y equals 2. And you can see from the way they're written, the x's line up and the y's line up. When I give you problems, they will typically already be written like this, so step 1 will be done for you. But if you're creating your own equations, like in the chickens and pigs task, you will need to remember to do this to use elimination. Our second step is to compare the coefficients for the x terms and then compare the coefficients for the y terms. What we're looking for is we're looking for matches of the number. We're not paying attention to sign at this step, just the number in front of the variables. If one of the variables, either x or y, has coefficients that are the same or opposite, so 2 and 2 or 2 and minus 2, we can continue to step 3. We're good to go. If neither of the variables has coefficients that match, we're going to need to use the multiplication property of equality to multiply one or both of the equations by a constant, a number, to make the coefficients of one of those variables match. Those are typically slightly more difficult systems, and you'll see a couple examples of those in a later video. We're going to focus today on cases that fall under A. One of the variables has coefficients that match. Once you have a variable that has matching coefficients, now we look at the sign on those numbers. If the matching coefficients have the same sign, we're going to subtract the equations. If the matching coefficients have opposite signs, we're going to add the equations. The goal here is to eliminate the variable that has the matching coefficients. We want to get that variable out of our system. So going back to our example, it's the x variable that has the matching coefficients, and those variables have opposite signs. One is positive 2, one is negative 2. And I know that 2 and negative 2 are a zero pair. If I add those numbers, the answer is 0. So that's what we're going to do. We've got opposite sign coefficients. We're going to add these equations. When we do that, that 2 and negative 2 becomes 0. Those x's drop out of our system of equations. I'm going to continue adding from left to right. When I add down the y column, 3 plus 1 is 4y, and 6 plus 2 is 8. I now have a single equation with one variable. That's something we know how to handle. Our next step is to solve that new equation. So we're going to take that equation and get y by itself. Typically, if you've done step 3 correctly, all you should need to do is divide by the coefficient in front of the variable. So here we're going to divide both sides by 4. Those 4's will cancel, and 8 divided by 4 is 2, so y is equal to 2. We now know that those two equations, if I were to plot them, cross at a height of 2. Now we need the x value to go with that y value. To get that, we need to substitute the answer we just found into either one of the original equations and solve for the missing variable. So here's our work from the last slide. We know y is 2. I'm going to pull that original equation, the first one, 2x plus 3y equals 6. And everywhere I see a y, I'm going to substitute in that answer of 2. So that equation is going to become 2x plus 3 times 2 equals 6. We can see that substitution. Y became 2. I'm going to simplify that multiplication problem there. 3 times 2 is 6. So 2x plus 6 equals 6. And from here, two-step equation. We saw those last semester. Get rid of the constant, get rid of the coefficient. So we start by subtracting 6 from both sides. On the left, that leaves me with 2x. On the right, that leaves me with 0. 6 minus 6 is 0. Last step is to divide out that coefficient. So I'm going to divide both sides by 2. On the left, those 2's will cancel. On the right, 0 divided by anything is 0. So x is equal to 0. So we now know this original system of equations is going to cross at 0, 2. Remember that you should write it as an ordered pair, 0, 2. So you need to take that x equals 0 and that y equals 2 and combine them into that ordered pair format we've been using with our other methods. Okay, that's it for the how-to method. There's going to be a series of videos with examples. I would encourage you to watch each of those and fill in the examples on your week 3 packet. And I will see you in our next class meeting.